Well, hi, good morning. Thanks so much for joining me in my shop here on the 4th of November. So before I came in the shop this morning, I started wondering, what am I going to do with this radio now? Yesterday I did some experiments, blabbed too much about speaker and the funny cone vibrations in it. By the way, while I was blabbing about that, I forgot to use the main descriptive term for that effect, which is standing waves. I don't think I even said the word standing waves. So if you're a ham radio operator, you know all about standing waves. Standing waves and the cable that goes out to your antenna is a big issue, can be a big issue. And even in the room here, when I mentioned about the sound in the room, is a very complex, weirdly shaped thing, especially at a little bit of higher frequencies. Standing waves. I should have said that word, so I've said it now. Okay, enough of that. What about this radio? So it seems to be performing kind of okay. A little weak here in the shop, but I'm sure if I took it outside or into another room in my house, it would work better. Does it work as good as other radios? Well, no, because I pulled this one down and demonstrated that, yeah, this radio is pulling signals out of that ether. This guy's not. So I wondered, what can I do with this radio today that might be interesting and fun, and we might gain some insight from in some way. I just made a little observation, which I'm going to talk about in a second, but I thought, well, maybe what I can try doing, without promising or knowing for sure I can do it, is look at the signals coming in and out of the detector. So let's say this block here, this is good. This is my detector tube. Then on one side you've got the antenna and all of its signals coming this way. In some radios, let's say this is the one you're after, you've tuned the radio to. In some radios, these ones get suppressed a fair bit. In this one, to some degree, because of the antenna is a tuned circuit itself, so these more distant signals do get attenuated. But still, there's stuff here coming to the detector. What's on the other side of the detector? So there's a couple things to consider. One is, if there is a frequency of 100 or 460 kilohertz, we'll know that because it's going to come out of the speaker. So we know there's at least one there, provided the radio is tuned into something. What else is over there? Before the IF circuits, right after the detector, what all is coming out? So I'm going to try and figure out a way to see that using my SDR radio. That's the modern secret here, opportunity that we all have to see deeper into these things than we could normally. I go back 20, 30 years. There was no way to do this stuff, or very, very difficult ways to do it. And that's why I think it's really quite a mystery as to what's happening on the other side of this tube. Now, no doubt, through the ages, the finest radio engineers have understood what's going on. Well, I'm not one of them, so maybe I can discover this by using the SDR, snooping around, and see what's coming out. That's what I'm going to do. Good luck to me. So, once again, you're along for my ride. I can't guarantee I'm doing things the smartest way when I do it. We'll try something and see what happens, and then just go from there. Now, the observation I made while we were chatting here is this arrangement. This is a little unusual, what's been done here. Normally, you wouldn't have this wrapped around the center here. It would just come straight up and out. So, no doubt, this is a result of somebody replacing the string. The string does look new. It's very dark, black, and in good shape. So I'm guessing this is brand new. Well, brand new. New from the last guy who worked on this radio. And I think when he put the string on, it turned out he had too much string, and he couldn't just let this go straight, and he just bent it around here. Well, that's interesting. I got to remember that. That's a trick even I could use someday, doing one of those horrible string jobs. So, how should we do this? We should take a look at what is arriving at the grid of this tube. This is the mixer tube, and what is leaving on the plate. Doing this with the SDR is a little risky. If I blow this radio up, I'm not going to cry too much about it. This is very inexpensive. I think I paid $40 for this quite a few years ago. Now you can still buy this one, I believe, or there's many others like it that will do the same thing, do a better job. This one has a lot of problems. This one has a lot of birdies in it, and weird stuff goes on inside here. So it's not the best radio, but so I'm willing to risk it a little bit. I'll try not to risk it, but of course we are asking the question: what is on the plate circuit of this tube? And one thing that's on it is a couple hundred volts. Well, in this radio, it's more like 100 volts or so, maybe 75, in fact. That's still enough, I'm sure, to burn the front end of this thing out if I allow that to reach it. So, got to think about this a little bit. Might be good to look at the schematic in this fairly simple radio and just have a look at it and see what comes to mind before starting the experimental process. Okay, here we are looking at the schematic here. Let me just kind of shrunk it a little too much there. So what I'm talking about is this tube, what's coming into it from here, and what's going out here. I'm not going to worry about the oscillator, the local oscillator circuit here. I'm going to ignore that. Well, that's an interesting question in itself. We imagine this to be a single oscillatory frequency. What about the harmonics in this? It'd be interesting to look at that too. You know what? And when I'm doing this, we might very well see this stuff. I can turn the local oscillator off quite easily by just shorting some of the plates on the tuning capacitor like I did yesterday, so we can make sure it's out of the picture. Looking at what's coming in here, can't be too many surprises. This is a bit of a tuned circuit. Well, it's more than a bit of a tuned circuit. This is a tuned circuit here. So maybe I should be circling this, in fact, right here. So, could literally take my SDR antenna and connect it right here. Now, is that going to, the question with doing all these tests is the test equipment disturbing everything, and what you're seeing is baloney? That's very hard to figure out. Very, very difficult. I guess I could be feeding a known signal in, maybe from a signal generator, attach my SDR in some way here, maybe with a resistor or capacitor or something like that. And meanwhile, listening to what's coming out of the speaker and determining if what I'm doing is really upsetting the whole show. At least the part we can hear, the part that's coming through the IFs and getting detected here. So that would be first step, and it can't be any surprises here. What will we see here? We would see what's on the antenna. I mean, it can't be really any surprises here, except it's going to be tuned to some degree. There's going to be a roll-off. It's going to be the I'm not sure what the right term is. First order roll-off from a tuned circuit. So many dB per frequency. We might be able to see that on the SDR, in fact. That might be interesting in itself. Oh, we could see where this is tuned as part of the alignment process. In this case, we can actually see the tuned effect of this. That's got to be first stage. What's going to go on in the second part, trying to look at this, is a much different affair. This is a lower impedance here. I can tolerate a little more monkey business, but not this. This can't tolerate too much monkey business. If we look at R3 here, it gives us an idea of the impedance of the... Hey, where's R3? Well, what happened? What did I do with R3? What? There is no R3. Did they forget something on the schematic? Look up here. They've got two diodes, and what the engineers have done, they just joined them together in happy matrimony here, and they're just doing the same thing, each one of them. It might as well be one diode in here, but the tube comes with two. So in this case, the engineers have joined them, and then they're tapping off the AVC voltage, and then they don't want to hook the front end of the radio up to here because this is fairly low impedance. It would just drain everything here. It would just kill it. Same thing I'm considering, in fact, as I sit here thinking about how to examine this. It's the same basic problem, and they solve it by putting a big resistor here. This has got to be a couple megohms, something like that. Since there's no DC flow of current in this circuit because it eventually dead ends in the grid, there's no voltage drop here. So you get a couple of negative volts here, they will appear over here, and the voltage here will increase or decrease in conjunction with this, affected by the capacitor here that I changed yesterday. Yeah. But this radio is done differently. Here they've separated the two, well, there's the 2.2. This is 2.2 megohms right in here. So this is interesting. I've not really recognized this before, but they're able to use this diode to generate the negative AVC voltage straight on to, wait a minute, oh yeah, that's right, this is the weird radio. Weirdly how they've done that. Okay, we'll ignore this. I don't know what's going on with the suppressor grid here exactly, but smart engineers figured something out. Generally, the high impedance is here, and that's because all these things are going to basically open elements in a glass tube, open wires, dead-ended circuits, open circuited circuits. So it wouldn't take much to affect the AVC voltage here. I'll put a capacitor to my SDR. I was bound to do that anyway. That should preserve any DC voltage that's here. But the impedance into my little radio there is probably a few hundred ohms. So if I just hook it up, even through a small capacitor, it may be placing a relatively low resistance here compared to this 2.2 hidden over here. I gotta be more like 10, 15, 20 megohms. So put a capacitor and say a 10 megohm resistor, and hope my little SDR can sense that. Still, there's enough left out there for the SDR to react to. SDR, it's a good radio. You should be able to spot a microvolt effect, that kind of thing. Well, there's a lesson right there, just how this was done as compared to this. I wonder if this radio came out, well, it's the D, so you can think the A, B, and C came out first, and by the time D came along, the engineers had really discovered some interesting stuff. Here's another difference. Look at how the oscillator's done here. There's something quite different going on down here. Using this would appear to be an open wire close to this coil. So loosely coupled, very loosely coupled, like a sensor. Well, look at this. If this is how they're doing it in this radio to get a signal onto the grid, bearing in mind there's a fairly strong signal here, could I do that with my SDR? But literally hold up an open piece of wire, I don't know about that, right near here. This must be the target of picking up junk. So this coil is inside the chassis, kind of contained in the chassis. The chassis is open at the bottom, but on the other sides there's a metal chassis there, so maybe this is protected from the outside world. Because I think, if you could take a wire here and run it out here and stick another antenna up, you'd have antenna signals going right in here. There's this other radio, you know, this is all so low impedance. I can't imagine that this would be affected by tiny signals floating around in space. I don't know, just talking through my hat here, just making things up. Just kind of piecing it together as best I can, but I could easily be wrong about all this stuff. Or there's other factors I'm not aware of. It's just interesting how this has changed from one model to the next, from the C to the D. Well, there is no C. Where's the C? 541A, 541D. What happened to B and C? B and C didn't make it. They took them all the way to D to sort out these changes. Just making up a story here. Okay, I think I'm ready. I think I'm ready after a little bit of coffee to actually try some stuff here. Okay, now just bear in mind I am winging this whole thing as I am in most of my videos. In fact, essentially all my videos. I don't prepare an awful lot for them. I just turn on the cameras and get going. So, with the radio here operating, let's just tune in the signal here. Try anyway.
So, his players and his guys, they have a little bit more room for error. He's not putting them in high-level situations where
Oh, that's pretty good. Yeah, fooling around all yesterday paid off a little bit. Okay. Now, the grid of the first tube is attached to the tuning capacitor stators. Stators are the insulated element in the tuning capacitor. Right there. Right there. I can add myself in as an antenna by doing that. That's where we can pick it up and have it appear on the SDR. Let me just turn on the SDR here. So, turn this down. The radio's tuned around, well, it's tuned to 590. So that's an area of interest in itself. And what you're seeing on the SDR right now is just the result of the SDR leads just hanging here. So if I touch this, it should go way up. See, I'm somewhat of an antenna. And I'd like to attach this right there, except don't do it. I'm worried about a couple things. First one, I really don't want to disturb the radio too much, or else the whole test is baloney. I'm going to put on a capacitor. You know, this is pretty long. This is going to be an antenna too. This is probably going to kind of wreck the situation right away. Let's see. That makes a little bit of difference. Not as much as I would have thought. There's nothing on the screen to look at. It's not connected yet. Let's do that now. I'm going to connect just one wire. So I believe what's happened here, I have to think about this a little bit. This is, putting this on, this is a long piece of wire here. It goes around and around over to my radio, the radio itself. The radio is connected to a computer. Goodness knows computers are full of noise, digitally generated noise of all sorts. So I probably just introduced a bunch of noise into the radio, either by antenna action or right out of my computer, just directly through these connections. So that's kind of wrecked things. The other thing is, where did the signal go?
that was a cutout. Didn't seem like a short answer.
The radio may have retuned, or the front end tuning cue, if you like, the response curve is flattened way out. It's no longer sensitive. It's no longer really got a tuned circuit at the front end. Let's tune around and see if we can find the station again somewhere else. all kinds of weirdness there. Oh, here comes that interference. What is that? So I hear this clicking interference almost every day in my shop. What is that sound? I mean, you'd guess it's a big motor that has started turning. But what happened there? It sounds like an old car engine, you know, and the spark plugs are just getting going. Nothing to do with this radio. Everything in my shop picks this up. Appears to be tunable. Okay, we'll ignore that. So I had reasoned out the other part of the isolation here would be using a large resistor. This is a large resistor. It's got a blue third band. This is a 10 megohm. It's actually 12. It's actually a 12 megohm resistor. It's gone high. Okay, so I don't have a clip on the end of it. We're going to remove this. So by now you should be saying, well, if you extend a wire out here and you pick up interference, well, wouldn't that be true of this little piece of wire here coming out of the chassis? Yeah, it would be. I guess the idea is the relative strengths of these things is such that the one you want is the winner based on the design of the radio. Okay, so now we're going to do the same thing, only this time I'm going to use this resistor. We'll see what happens here. What happened just connecting it? Okay, I'm looking at the SDR, nothing. So you can hear it clicking on and off. I'm looking at the SDR display very carefully. Right around 590, which is close to where that vertical red line is on the SDR. Everything's jumping around a bit anyway. Okay, so the reason I'm holding still and have frozen is because I thought I saw a wisp of smoke come through here. Probably just dirt on my glasses. That's what it is. It's dirt on my, my glasses. Well, this isn't good enough. The SDR can't see anything through this big resistor. Okay, we'll try I have another one here. We'll go down a factor of 10. So this is now a 10 megohm resistor. Let's just make sure of this. The worst thing you can have happen when you're doing stuff like this is what you think you're doing is not. What you're doing something else, and you don't realize it. So it's 1.1 megohms. 1 megohm. Notice I haven't hooked up the ground wire anywhere on my SDR yet. Sometimes I find when I'm doing this kind of stuff, I'm intending on something, I come across something entirely different, which is worth coming across. So that's why I'm happy to do this kind of stuff. So that's definitely making a difference on the radio. I'm watching the SDR now. Oh, even that doesn't make a difference. Huh. Okay, megohm, too big. So go down another 10. This is my box of 10s. So it's 10, 100, 1,000, a megohm. All I gotta do is look in the tray for the right color, third color. Orange. 10K. I'm not trying, we're skipping 100K. We're going to 10K. I found out I can do this. Oh, now that does something. Okay, we need the 100K. 100K would be a yellow. Pick anyone with a yellow. This is a pretty old resistor here. Maybe quite a bit. May have gone high, but would only be like maybe 20-30% high. Big long wires. Wait a minute. How can this be? So that kind of interference in his voice, if we listen to his voice all garbled, that's called intermodulation distortion. Okay. Ground should probably be on the B- line, which is not accessible above the radio. I have to get it underneath, so we're going to just keep leaving that aside for now. So the amount of effect from a 10,000 ohm resistor. The amount of effect from a 100,000 ohm resistor should be quite a bit less. Looks like a lot more. What's the matter? Do I not know my resistor codes? $3,000 ohms. Wow. 3,000. It's in the wrong bucket. Let's grab another one. Yellow third band. Uh-oh. This thing just did something I've never seen before. It came out and said, the unit is uncalibrated. What is all? I've never seen any of this stuff that's coming up on the screen here. Somehow it's determined itself that it's uncalibrated. Is that why I just got 3,000 on there? I don't know. Let's push the button and see what happens. Okay. So that's 100K, brown, black, yellow, 100K. Well, what am I doing here? Right. Thrown off, get distracted, and then like I suffer from the room effect without even leaving the room. There we go. The room effect, you know, the memory effect. That's when you get to where you're going, you don't know why you went there. You should read up on that. Oh, it's doing it again. Not calibrate for calibration clamp. Oh my gosh, I've never seen this stuff before on this tester. Well, I'm going to have to deal with that. Okay. I think the reading was valid though. So this is 100. Yeah. I think we got somewhere now. Is it so it's hardly affecting the radio. I mean, And in the end, I think what I'm going to find out is if I'm able to draw any signal off into my SDR, it's going to be too much for the radio. And so when I apply it, I'll be testing a circumstance that's not normal. So the results will be invalid. Well, let's see. I could shorten the leads here. I could solder this on, but I'm not going to do that. I could also apply the ground either to the chassis or the B minus. Let's tune the radio and just watch. Oh, don't touch the radio. Don't touch the radio. Okay, so if you look right around 1 megahertz, you can see the local oscillator traveling along. And the radio's tuning should be 460 kilohertz below that. So if we go back to a million, the local oscillator go that low? Right around a million now. And we look down 400 kilohertz, that would be 600 right at the bottom of the band. I'm looking for a little hump. What I found in doing this with other radios, this kind of thing, not exactly this, is sometimes the little hump I'm looking for right around 600 it's really the response curve of the resonant antenna and the capacitor working together. Sometimes you can't see the hump. What you see instead is the signals that you see there. They're mostly noise signals up in there. You'll see that one by one they grow up. They grow up as you tune across. You don't actually see the sort of the floor come up. Now can we see that? So according to the dial on the radio, we're just below 600. I would say no. I mean, if the effect is there, it's too small to see. Okay. Let's go back to the capacitor. Using this size resistor and the radio itself, I have not connected the other lead, so the radio's impedance should appear very high, I think, to the radio here. If I hook up the other lead, I think the impedance of the radio will come into play and will really knock the wind out of the very fragile signal at this point in the radio. Now we'll tune it and see if we can see anything happening. Okay, you can see the local oscillator very clearly. You can see nothing in the front end happening. So this is a direct connection technique. I don't think there's a solution here. We need some kind of high impedance input radio with a high impedance input. I've been doing all this on restricted voltage, but it's 105. That's plenty. Okay, another different approach. You may have noticed this coil. I may not have noticed it because it wasn't on camera. I'm going to sniff around with this coil. I'm going to hook it up while I'm holding it. So how come everything dropped? Wouldn't things go up when I hook up a coil? Well, it's a short circuit. I've basically shorted the input to the radio, which raises another question. What if I short it out like that? So you see some signals there that are left behind. Pick the big one there in the middle. Just keep your eye on it. Yeah, it didn't change at all. You see that? So I'm talking about the one that's right above my finger here. Watch it. That's probably an internal signal in the SDR. That's what I would derive out of that little experiment. And so the other ones are too. Okay, so there's lots of problems here. We gotta go with what we got. Okay, so now what do we want to try to sniff with this? The same basic thing. Can we find it here? What if I just... Oops. So that's the local oscillator you see going up. It's even bigger if I hold the coil near the oscillator part of the tuning if I'm on the antenna part. Ooh, look at it go. How do I know that? She's working great. This radio's just getting better and better. I'm not even doing anything to it. The signal may be around this tube, but the tube has a metal can, so the signal's kind of hidden in the can. Can't get out, or can it? I don't think so. I don't think that's much different than just laying it up against the chassis here. Notice the whole time that signal light pointed out over here just remained sitting there. Coming out of this tube is certainly the IF frequency when you have something tuned in. Where'd it go? There's no evidence of any kind of front end hump or anything. On other radios I've done this. It's easy to see this effect. Not on this one. Let's just stick it right in here for some stupid reason. What's that? So I'm watching very, very closely the noise signals that are right around where we're tuning, right around the 590 area. I'm watching very carefully, I can't put my finger up there, to see if any of those little noisy peak things are actually growing up as I tune. It's very hard to spot this. Well, is that 590? So, again, right above my finger, there's a little blip. That might be 590, the signal we're listening to. We can find this out. I'll turn this radio down. I'll tune the SDR right to it. Let's just get it right on the money here. Oh, no, it's not that. Wasn't it this one? 577. It's got to be 590. 590 is there. There's nothing there. On the SDR. Okay, so now the red line's marking where we would expect the radio signal to appear. Let's do this. I can jack this up a little bit. As I just slip the insulated part of the coil under there, I shouldn't be in any kind of trouble. Well, it's kind of interesting in a way. When I shove it under, a number of things disappear. If you look at the red line, just to the right, left of the red line is a peak of some sort. And if I do this, once I get the coil right under, it disappears. How interesting is that? I don't know. Okay, so is that coming out of the radio somehow? Let's switch the radio off for a moment. Repeat. Still there. Now I turn the radio on. Turn it off again. That's a tough one to explain. Turn it back on. Well, this is the kind of thing I just love. Doing something and going, what the heck is that all about? So the SDR has an ADC circuit, automatic volume control or automatic level control, in it of some sort. But I'm looking at the other signals that are showing, they're not changing, just that one. Okay, so radio on, signal not apparent. Radio off, signal shows up. Tune the radio. What could possibly happen? Some of these front-end experiments can be done with the radio not even turned on. It's just passive circuitry you're dealing with. Well, I don't see anything happening there. That's pretty curious. I don't know what to make of that effect. Let's turn the radio back on. That's really curious. Wow, I'd have to... Turning on the radio gets rid of a noise that appears to be nothing to do with the radio. A noise signal or an interference signal. I shouldn't say noise. I should say some kind of interference signal. Wow, yeah, that's outside my box for sure. I don't know. I don't know what to think of that. Okay, so a little distraction. Now, so we're having no luck in seeing the front end tuning of this radio. What about right off the antenna? What if I took the coil? Let's turn it up. That's more interesting. Now that's more interesting. So the radio is currently tuned to 590. The red line on the SDR, you can't quite see it because it's off the top of my screen, the way I have the thing set up here. But it's tuned to 590, so the red line is showing 590, and there's something there. Tune the radio now. Okay, I'm going down in frequency. Okay, so now we're seeing the effect. Okay, so right above my finger here, right at the end of the blue bar that marks the medium wave band, and on the front of the radio, see we're right at the end of the band here. So there's the front end tuning visible. I'm going to move it up. You see, it gives a little boost to every peak along the way. We're at probably 570, maybe 580, 590. You can see the 590 peak going up and down. Is that the 590? Where's the voice? So doing this has done something to this radio. Hasn't killed it, but it's weakened it. We have a chance here to double check the alignment. Since we know now where the front end tuning is occurring, the front end tuning is adjusted with this screw. We'll move that this way, move that back and forth. The boosted area, if you like. Keep tuning upwards. In some radios, the noise floor would have a nice hump in it you could watch, but this one, not doing that. So now I'm interested in the area right above my finger here. This is where the radio's tuning. You see 3 peaks hopping up there, about the same size or tuned along. One disappeared. The left one got a little bigger. The left one got a lot bigger. The left one disappearing entirely. So is that, now that one that's sitting there, is that one that's always there? No matter what we do? Turn the radio off. Where'd it go? Okay, I'm looking at the wrong thing. I looked away. Okay, so I'm looking at the peak now. Peak is the one that's right here. Nothing to do with the radio itself. It's jumping around, so I'm pretty sure it's a received signal. Whereas if it was developed inside the SDR as spurious signal, I think it would just be rock solid like that other one we were looking at over here. The reason the SDR is so lousy is because it was never intended for this purpose. It was intended for receiving TV signals. So you can kind of see where we are. We're approaching that big signal, the one that's fixed all the time, and see, it doesn't change at all. I'm going either side of it now. You can see the things. I'm going to do this a little quicker. You can see it much easier. So I'm looking over in this area right here now. Now it's quite clear to see the front end tuning. Look at it. Something I've noticed in these radios too is the front end tuning usually gets broader and stronger at the higher end. So we're right at the top of the dial now. And so on here it's 15, 16, 17. We're at 1700. Oh, okay. Where did those guys just come from? I didn't notice them. So I'm talking about the things that are running around now. There's another weird effect. That's something I have noticed since I started using the SDR. How come they weren't there before? Where did they come from? Would I just not see them? Notice I'm hardly turning the tuning and they're just racing back and forth. I used to attribute that to the SDR's weirdness, but now I think what we're seeing is an output from the mixer tube. Even though the loop is up here and there's distance and all that, I think that's an output product of the mixer tube. And this is what I believe, it's signals that are mixing that have no business being in there at all. Well, there's something very strange about this capacitor. I don't know if you can see this on camera. If you look at the capacitor, yeah, you can see it. Let me get my stick here. When you look across the top of the capacitor, you see a divot right here. At first I thought, oh, the plate is bent over. But it's not bent over. It actually has a piece nipped out of the top of it. A little piece of metal missing here. Never seen that kind of thing before. It's a perfectly straight plate. There's one plate has a little chunk out of it. Is that on purpose? What is that? Never seen that before. See, that's why I do this stuff. You know, I used to be an inspector of a sort when I worked in the power company, and one of the principles I taught myself was, the longer you look, the more you see. It's just that simple. So you need an excuse to keep looking. So I do these experiments. It's a little bit of an excuse to keep looking at the radio, looking at the test equipment, looking at everything, waiting for something to come out that I would never have imagined. What about these racing frequencies? Well, we can't deal with that right now. It's only apparent at the high end, maybe. Let's go down. Yeah, see the rate, well, no. there's a real high-speed racer right in this area here. Just watch how little I'm moving my hand. Now you gotta wonder, like, are those things significant? Like, are they coming out of the speaker? Is it an artifact of my SDR, in fact? And nothing to do with the radio? So the radio is tuned to around 11 right now. So if I move that a little, tune this, because I'm tuning the radio, when that gets around the 11 mark, what happens? Okay, so we're tuning, we're still right around, I'm hardly tuning the radio still. So I'm going to make that little blip go through the 11 area, 1100. Well, there was a weird thing. But I think that's not that racing guy that we're hearing. I think that's some kind of noise signal we're picking up from the antenna in a more normal way. So don't know what to make about those guys. Except I think they are an output product of the mixer. I think yesterday's video I said something about junk coming out of these tubes. I think we're seeing some of it here. If it's not 455 kilohertz, it's not going to make it to the speaker. But what it could be doing is it's in there with its weird brother, its cousin's in there, and they're going through this mixing tube and they're producing even more products. And I think to some degree these racing things are products. I don't know. I don't know what more to say about it. You know, when you mix signals, you get the two original signals and you get the sum of them out here, and you get the difference down here. The difference is the one that we're interested in a radio like this. Well, I don't know. What else are we going to find out here? So we can kind of verify the tuning of the front end. I think we've kind of done that, actually. So just by looking at the front end dial, I can just line this right up with line it right up with the SDR screen. That's interesting. So now to some degree, I mean, this is a little bit of a small. Oh, I can fix that. We'll zoom in. Zoom in. I can make these match size-wise. Zoom way in. Oh, scared the living. There. That's a close match to what's up on the screen. Close enough. Well, it's not the local oscillator we're interested in. Where did our nice peaks go? What happened here? Did I lose everything somehow? What happened to the front end effects we were seeing? Moving this had that effect? Moving the radio around in my shop? That can't be the case. What happened here? We were having so much fun there for a while. Because the so I'm looking about here on the SDR, right here. When I tune up here, okay, so on the SDR that peak is around 7. Oh, I don't have this scale at all. Correct. I need to zoom in even more. I can't get this much closer to the other, I don't think. So I'm just being fooled by my own experimenting here is not quite right. Okay, hang on. We're going to lower the camera down. I have to drop the tripod here. can't get the tripod unlocked. Okay, never mind that. One tripod leg that won't unlock. Okay, I still think we probably got enough out of this anyway. Interesting, if I got this set up a little better, we actually track it right across. So 590. Cannot see the front end effect. Cannot see the 590. Because the radio red line up there is right on 590. Oh, you know what I may have done? I may have rotated the radio. I had it more like this. Okay, so there's a distinct peak right about here. Very distinct. The SDR is slightly delayed, about a half a second almost. In the tuning, maybe I'm tuning it too fast. Okay, so there's that peak that looks like it's around 610 or something like that. We may not hear anything, like we don't hear anything coming out of the speaker, just some noise. Let me just tune off a little bit. So you can tell I'm tuning something in. In other words, the distance between the local oscillator and that signal is exactly the IF. It's coming through. A different frequency is coming through. So let's hear what that sounds like on the SDR. So I'll set the SDR rate to it. 620, 618. What's it sound like? Nothing special. Nothing special. So that's an unmodulated noise signal of some significance that when you tune through it on a radio like this, since there's no modulation, you don't hear anything. You might hear a quieting of the radio because that signal will still be detected, rectified by the detector. There will be a DC voltage that will be produced. The DC voltage, negative DC voltage, will be used to quiet the radio. So as you go by it, you might hear a quieting effect. Sounds almost like there's a hole at that point in radio reception, but there'd be no significance of that. Is if you had a station of similar strength right next to it, let's say 4 kilohertz away, you might hear a 4 kilohertz whine coming out of the radio all the time. It wouldn't go up and down in pitch. Just as you tune through, it would go up and down in pitch. Would it? No, it would not, because the transmitting station and the noise signal are fixed and they're not moving. So there's always in my example, 4,000 hertz between. You'd hear it. You'd hear a constant whine. So if we tune to our station here, where'd it go? So now we hear a tone. One tone, the frequency, it's very harsh on my ears, harsh on yours too. The pitch is not changing. The pitch is the same, it's just coming and going. That horrible tone. That's got to be this situation with a noise signal right beside 590. The two of them are going through the radio. Now there's another one, a sweeping one. So I do this. You hear the pitch go up and down. Now that's got to be because you have two signals, and one is moving relative to the other. Okay, there's no whistle here. There's a whistle here of a different frequency. Also fixed frequency. Again, it's got to be this thing happening to like a noise signal, and well, I'm not really tuning in anything else. I could do this all day, by the way. I don't think I want to. Well, we didn't get anywhere near some interesting stuff. We never got to the other side of this tube, but I'm going to call it off now. Because how long have I been going here? I think I've been going for some ridiculous period of time. Maybe tomorrow what I'll do is I'll jump to the other side of the tube. We'll look at the IF, the output of the IF also. Try to spot that on the SDR. Try to examine what's going on in it. Maybe that'll give us some more insights about some of this other stuff. And I don't have to do all this with this radio. I have more radios I got to bring in and fix. And then they become a target of experimenting, and it gets really interesting. I think it will get really interesting because different radios are going to behave differently, I would think. Or put the different radio in the same noise environment here, get the same crazy results. What I would hope happens to me, and maybe you too, is you become very, very aware of what these noises we're hearing on these radios actually are telling us about the operation of the radio. And that may guide us towards hunting for certain kinds of problems. You know, fixing TV sets, to some old TV sets, to some degree is easier than fixing these radios. It's not, but because there's a lot more to a TV. But what a TV has is it has a picture. And the picture reveals all kinds of things that are going wrong in the TV. The classic one is the picture no longer fills the screen, and you just have a shrunken picture on these old TVs. Hopefully you're old enough to remember this kind of thing. You see that? Well, it tells you it's either the vertical oscillator tube or the vertical output tube. So there's no picture here, but there is a picture on the SDR. It may give us insights that are very hard to grab and maybe even are not well known. You know, I was showing my great book here, Elements of Radio Servicing. So this book is from the 50s, I think. Look at this. Some previous owner wrote all this stuff in the book. When was this book written? William Marcus and Alex Levy. Oh, there they are. Hey, I've worked on one of those radios. McGraw-Hill, 1955. And originally, it looks like originally 1947, 1955. 1955, do you think they were whipping out their SDR? I don't think so. Do you think they had a computer to help them out and do all this kind of stuff? I don't think so. So could it be that certain insights in the operation of these radios are so obscure that they can only be discovered today with the modern technology we have available? Especially this SDR, which has turned out to be a fantastic thing. I really, really like using it, even though it's kind of a crummy SDR. Well, I think that may be true. So is there a potential here to make discoveries through experimenting that you could read a dozen books and never ever hear a word about it? Yes, I think it's possible. And I would love to make those discoveries. That's where the fun is, isn't it? Okay, I'm done for today. Well, thanks a lot for watching. It's kind of a rigmarole, a run around in circles. What I invite you to do, if you got a shop, you're doing these radios, do the same thing. See what you can find out. And I think it's a lot of fun. What else are you going to do with these things? You're going to fix them up and sit and listen to them? I don't think so. So thanks a lot for watching, and I'll see you on the next video.